So this is the continuation of Don't Need the Yellow Snow series. This is the 12th video. If you are just joining from this, just starting from this video, you're going to want to clone the repository on GitHub called Programming Rainbow Yellow Snow C SDL2. And since this is the 12th video, you're going to want to take the source that's in the video for the last video, which is the 11th video, and you're going to want to either copy this or rename this to the source folder and delete the source folder, or copy the files in. However you want to do it, we are going to be using the code from video 11 since this is video 12. Okay, so in video 11, we created a title screen a title that came down and then it stopped and it just sat there and it let the snow fall. And whenever you want to start the game, you just press space to start the game. So this video, we're going to need to switch. We're going to need to clean up how the pausing and the playing of music happens, because we'll need to take that into account. But I also want when the game ends, if you hit a yellow snow, when you're looking at all the snow stops falling and you're looking at your score, and if you sit there for a couple seconds, or maybe you're getting a drink or doing something else, I want the title screen to start coming down again and the snow to start falling again after a set amount of time, say 5 seconds or whatever you want it to be. So to do that, we could do this in many different ways. We could put a timer on a function and then have the function call, but what I would really prefer is to put something on the event stack. So I know exactly when the thing is going to happen. So if I just have a function on a timer, that function could just turn on in the middle of all the code. I don't know when it's going to be enabled. It could be reading events, it could be drawing stuff, and then suddenly a different thing is turned on. So I want to control when this event happens. So what I want to do is I want to put it on the event stack. So when we go through the event queue, I can pull it off there. So I know when I'm checking this event that has happened. So that's what we're going to be doing in this video. We are going to be creating our own user event, and then we're going to be pushing it onto a stack with the timer and everything else. So let's first look at what the events are. So we've already been using the event for checking the type, whether it's an SDL quit type or it's an SDL key down type. So here's the quit one that we've already been using, and there is the key down. Not sure where that one is. Key. Is it up here? Yeah, it's in the key events. But anyway, so we need to make our own event. So the structure of the event is kind of it's a union, but it has a structure inside of it. But so the SDL event, we're going to be calling it we're going to be creating an event. An event is going to have a type, which is going to be user event, but we're going to give it our own name. And then we can put some code in it, we can put some data in it, but we actually don't care about any of that. We're not going to be worrying about putting code in it. We're not going to be worrying about any data in it. The only thing we want to do is set the type, so that when we go through our event loop, we can see, oh, this type just happened. The say game reset event, if we want to call it that. The game reset event was triggered, so now I can do what I want to do in the game. So basically, we're going to be creating this an SDL event, which is going to have a member called type, a member called user code, user. This is the user is a structure inside of this union. It's going to have the union has a member called user, and the struct, which is a struct, and that struct has a member called code and a member called data1 and data2. So we're going to create this, and then we're going to push that event to the event stack, okay? But what we're going to do is we're not pushing it right away. What we're going to do is this function that is going to create this event for us and then push it to the stack, this function is actually going to be called with an SDL timer. Here's more event types. we're going to be using a user event, but we're going to be using in this the push event. We'll talk about that in a minute, but we're going to be using this SDL add timer, and this is going to allow us to call a function after a specific amount of time. And the function that we're going to call is the thing that pushes the event onto the stack. So no matter where we are in the code, the event's going to go on the stack. So then when we do reach to going through the events one by one, now that's the time that we get our information back out. So it allows us to do it in an orderly fashion. So we're going to be using this function to set a timer that another function will be called later, which is going to be what's creating the event. So let's start building this out and seeing what it looks like. I'm going to, so the user events, this is actually, I believe, an enum, or it's just it's some kind of macro, but it's a specific number, and I think it's around 32,000 or something like that. But basically, if we wanted more than one event, we could call the first one user event, and then we could call it user plus one. So it's just going to add one to this, whatever this number is. And if we wanted 2 plus 2 plus 3 plus 4, since we only have one event, I'm going to be setting it here. So I'm going to take this right here, and I'm going to go into our main.h, and I want to create our own event that we can look for. So it's going to be game reset event with an N, not an M. And I'm just going to use the user event. So that is an internal, I don't know if it's an enum or it's some kind of macro that it's got a number for us. But if I had say 5 events, I would do this same thing here, but I would just do a +1, +2, +3, +4, +5. So that would be one number, and the next one would be a unique number again. So this is just so I can do it. I don't want to pull this user event. That doesn't mean anything to me. I want to give it a name. So when I see this event now, I know it's the game reset event coming out of there. So we've set that. Now we're going to make this function that is going to create the event that will be pushed onto the event stack. So we're going to put that in game. Because the fact that this function, let's go back to the timer real quick. Because the fact that this function is going to be used with this SDL add timer function, it must have the signature. The function that we're going to be calling needs to have a uint32 internal, and then it needs to have a void params. It needs to have these two things right here. If it doesn't have these two things, and this is the function that this is actually calling back, but the callback function we're going to create right now needs to have these two arguments, this top one and this bottom one. It needs to see them. This SDL add timer needs to see a function signature with those two functions. So they must be there. Even though we're actually not going to be using them, we have to put them there to be able to use it with this SDL add timer. So that is why we're going to be adding these parameters, but then not using them. And we'll see that here. So I'm going to put it right below the game reset. So I'll just put it right here. So it's going to return a uint32. And again, I'll explain why. But we'll call this game reset. We're calling it timer, but really it's the thing that's being called from the timer, but it's fine. This is actually the thing. When the timer counts down, this is what's pushing the event onto the stack. So uint32, and this is the interval. And then this is going to be void param, sorry, like parameters. Okay, and it needs to have this signature, not because of this function, but because of the function that's going to be calling this. It needs to, for one, be able to pass interval to it, because the SDL add timer function is going to call this function and it's going to pass a parameter. This parameter is going to pass this parameter to it, and it's going to be looking for this return. So it has to be set up this way for it to work. Okay, and like I said, since we're not using interval at all, because what interval is going to do, let's go back to this. I know this is a bit complicated, but what this timer function does is the very first argument here is how long in milliseconds before you want this function to be called, whatever is going to be populated in this function, which is what we're creating. So if I put 5,000 here, when I call this function in 5,000 milliseconds, 5 seconds, it's going to call this function, and it's going to pass that first number into it, and it's going to pass this third argument into it. Okay? But the return it gets back from the function, it's going to use to call itself again. So if I say 5,000, I'm calling my function, I'm not putting any parameters in, and my function returns 5,000, it's going to, after 5 seconds, it's going to call the function, but then that function is going to return 5,000, so it's going to call it again at another 5 seconds, and it's going to keep calling it in a loop every 5 seconds. And we don't want that to happen. So we could return this interval from this function. I know, and it's a bit circular thinking about this, but we're not going to do that because we want it to happen just one time. So we're going to cast this to void so the compiler doesn't complain. And the parameters as well. We're going to cast them to void so the compiler doesn't complain. We have to have them, but we're not using them. Okay? So we've cast those two to void. Now, before I said I don't like to declare a variable, I always want to initialize it, but because this is a union that we're going to create right now, the event union that we're going to push onto the event, since it's a union, there's no practical way of me initializing it. I have to declare it. So unfortunately, I'm going to declare this one. So we're going to say SDL event. That's the type, and we're going to just call it event. Okay, so that's our declaration. Now we're going to start filling it out. Event type. And this is going to equal what we created, the game reset event that we put in the main.h. And then the code is going to be just nothing. Sorry, this is the inside of the event union. This is the struct called user. User.code, and we're going to say it's 0. And event.user.data1. We're going to say this is null. And event.user.data2 is also null. Okay? We don't, like I said, the only thing we care about is this thing. We want this event to hit the stack, the event stack, sorry, and we want it to be of type game reset event. That's the only thing we're looking at. So now that we've created it, we've populated these 4 parts, we're going to push it to the event stack. Now again, we're not calling this function directly. We're going to call the timer, and the timer is going to call this function. So SDL push event. This is just going to push it to the event queue. I keep calling it a stack. It's a queue. Event. We're pushing the address of that. Okay. Now this is the return. Now watch this. Return. I'm just going to return 0. Okay. So what's going to happen is SDL add timer is going to take in. Let's just write the SDL add timer above just for a minute. So if we went SDL add timer, okay, it wants to see a number. So we said 5,000. And then it wants an address function pointer, which is just the name of this function right here. Game reset timer. Okay. So we can't pass this whole thing in. We have to pass just this. So it also needs to know what these are. And actually, it's going to use this first argument right here as this one. So the second argument is going to be the third one here. It's just going to be, we're going to say it's null. Okay? So if we did this right here, this function is going to have a little timer sitting on it. And after 5 seconds, it's going to say, yep, I'm calling this function right now. And I'm passing in 5,000 here. And I'm passing in null here. Okay. And the 5,000 is going to go nowhere. The null is going to go nowhere. This event is going to be created with of type game reset event. And it's going to be pushed to the event queue right here. After we've declared it, we've populated it. Now we're pushing it to the queue. And we're returning 0. An SDL timer is waiting for the return of this thing. Okay, it sees 0 and it says, okay, we're done. But if I were to do this, if I were to say return interval, right, and this wasn't here, if I did that instead, let's not worry about this, but if I did this, what would happen is this timer would continually call this every 5 seconds. So if you want something to happen at an incremented amount of time, this is how you would do it. But for us, what I want to happen is I want you to hit the yellow snow hits you, your game finishes, you can still see your score, the snow is no longer falling, you can't control your character, and if you don't reset it, in 5 seconds, I want the snow to start falling again. So yeah, this first thing gets put in here as the interval. This third thing gets put here. This middle one is actually the name of the function itself. And the return from this function is what add timer initially uses this time, 5 seconds. But then after that, it uses whatever the return is from here. And since we're passing 0 back, it's not going to happen again. Okay. So I hope that, I know it's a bit confusing, this one. It's like I said, it's a bit circular in thinking. You need what's first, the chicken or the egg? This function is calling this function, which is generating this event, which is calling this function to put it on the event queue. And then later we kind of have something watching the event queue. But this is all going to be so that we can make our own event and make it happen the way that we want it to happen. So this is our function right now, and I'm going to put the prototype of this thing. I'm going to copy this real quick. I'm going to delete this function because it's not going to be here. But I'm going to put the prototype of this on top. It doesn't need to be called anywhere else. I'm putting it just in the C file up here. I'll put it in line with where it shows up in the code. Okay. So that gives us an event that we can push onto the stack. It doesn't give us the timer, it just gives us the event. Now the problem with this whole event timer thing is say the yellow snow hits the snowman. Right then when it hits the snowman, we're launching the event, the timer. 5 seconds is counting down. But you don't wait 5 seconds, you just hit spacebar and you want to keep playing. Well, at the end of 5 seconds, what if that event still goes onto the queue and now we've reset your game? So say you're 3 seconds into your game and suddenly your game just resets. We don't want that to happen. So we want, if you have reset the game, we want any queued event that hasn't happened yet, or not SDL timer that hasn't called the event, the callback function yet. If any of that timer exists, we want to remove that timer. We only want the timer to carry on if you are not pressing spacebar. Once you have pressed spacebar, we need to remove the timer. So we're going to hold on to that timer. We're going to put it in the in main. So it's going to be, let me double check it here. It's going to be in game.h. in our struct. And it's going to be an SDL timer ID. So let's look at that again right here. Add timer, and it returns an SDL timer ID. So if you just were creating a timer and you didn't care, you just wanted that timer to happen, you don't need to hold on to this at all. But since we want it to be removed if the person presses space before the event happens, we're going to hold on to it. So this is the type that it is, and we're gonna create it in the game. Whoops. What am I doing here? Let's undo that. So game H, and this we'll just put it right below the double here, and it'll be of this type, which is SDL timer ID. This gives us the ID for the timer that we're creating, and I'm going to call it reset timer ID. Okay, so reset timer ID exists now for us, and back into game. So where is this timer going to happen? Well, it's going to happen when our collision happens. Handle collision should be happening right there on handle collision. Right here. And we're going to capture that timer ID that we're going to get out of this. So we're going to go game, reset timer ID equals SDL add timer. Now we're using the 5000. Now we could put this in the main.h, so we're not putting a magic number here. Let's just do that real quick. Main.h, and let's call it game reset time. Sure. Time, and we could just put 5000 here, so that you can change it easily if you want. That doesn't need to be a variable, but if you want to restructure your game to have a different timer, so we can do that right here. Game reset time. Okay, so we have the time. Now we have the function that we want to call, which is game reset timer. Sorry, game reset timer is the function we're calling, but we're not. This is a function pointer, so we can't do that. We're not putting the arguments there. Add timer is building it for us. That there. And the other thing is the null. We don't need anything for the parameters. We're not trying to do anything fancy with this. We're just trying to throw on the stack after 5 seconds a type of reset. Okay, so that should be that. So this is going to put it on, but now, like I said, we need to, if we've pressed a space and reset, we need to get rid of this guy if it exists. Game reset time. Why are we complaining about this? Oh, so yeah, I did the thing that you should never do. I put a semicolon there. No semicolons on preprocessor directives. Okay, now it's no longer complaining here. It just formatted it that way automatically for my LSP. Don't worry about that. I mean, you could do the same if you want. So, wait, did I? Yeah, the timer ID is here. So on our reset, when we reset the game with the space bar, right here, we're going to need to look at whether this timer exists, and if it does, we want to remove it. So I'm going to use an if statement. Now this is, since it's callocked, it's going to be set to 0 initially, and if we haven't set a timer yet. So if the timer ID does exist, we want to use this function over here, remove timer. And we don't care if it failed or not, but we do need the timer ID. And it won't fail catastrophically if your timer ID is no longer valid, but we're going to make sure that we clean up after ourselves. So we're going to do SDL remove timer, and the timer in here is going to be G reset timer ID, and then we're going to clear it out. Reset timer ID equals 0. Okay, so So when we have removed the timer, we are setting the timer to 0, or the ID of it. So next time if we press space again to reset, it's not trying to remove a timer if one doesn't even exist yet. So that has pushed it onto that's going to push it onto the event queue, and this is going to remove it if it's on the queue yet, but if the SDL timer is ticking down, but we've reset already. But we're actually not checking the event queue yet to do anything. When this happens, we need to actually set something up where what's going to happen when this gets onto the event. So this is a top level type that we're checking, like SDL key down and an SDL quit. So I'm going to create another one here. Case, it's not SDL, it's a game event, game reset event, which is the name we called it. And we'll do a break on this. So what will this look like? Well, we need to reset the title. Okay. We need to reset the title. And the other thing we want to do is we want to reset the music playing. But if that's if the user, so basically, if the music stops if the yellow snow has hit you, but after 5 seconds, since in the very beginning of the game when the title screen came down, the music was playing. We want it to start playing again, but only if the person hasn't said that they don't want, that only if the pause music is not set from the player. So we're going to do an if on that. This is saying the intent of the player. If the player doesn't want to listen to music, we're not going to restart it. So if not pause music, and I don't like the way this is. Okay. So then we'll do the mix resume music. Resume music. Okay. So that should take care of all of that. So basically, after 5 seconds, if you haven't pressed space yet, this is going to be thrown on, and it's going to see that this event happens. It's going to reset the title, which is going to turn on those 2 flags. So the snow starts falling again, and the title screen resets itself to above the screen and starts falling again, and the music is going to start playing again, unless the person has pressed the P key, which pauses the music. If that flag is set to pause, we're not resuming the music. I think there's another issue with the music so in the pause music function, we want to be able to resume the music if we're playing or if the title is showing. Because what will happen is if we try to unpause it, but we're in that, if we've paused the music already and now we're in the title screen falling down again, we can't press P and unpause the music now because we're not in playing mode. We're in a mode where either the title is showing or the title animation is showing with the show intro, one of those. So we need to let the music resume in that situation. So right here, the one that resumes the music, we need to just add an OR to this. A logical OR, and we're going to do the G, and this is it's a flag inside a title, so we need to get to it. And we're going to use not the show intro, but the show title, because the show intro is just the animation happening. But even when the animation finishes, the title still shows, so we want it on show title. And that should allow us to pause and unpause the music while the title is showing or while the intro is showing or any of that. Okay? So let's try all of that stuff. Hopefully I didn't miss anything yet, so that is a lot. So I'm going to do, since since I've been changing the main.h header file, I'm going to do a rebuild. So everything is there. I have to listen to this delayed, unfortunately. I'm going to pause the music. Oh, let me do it again. Okay, so this time I'm going to pause the music and unpause it while the title screen is coming down. So the pause and unpausing of the music works. I can't move my character, but I'm going to start playing the game now. Okay, I'm going to pause the music. Okay, I'm going to let the yellow. So the yellows hit me. Now I'm going to just wait. Wait 5 seconds. And the music didn't start playing because I actually told the music to pause that time. So I'm going to unpause it now. Reset the game. And now I'm going to do the same. I'm going to let the yellow snow hit me. The music is not paused now. So the music should start playing. Okay. It all looks like it's functioning correctly. So this time I'm going to pause the music so it's not playing. This time I'm going to, sorry, I'm listening to myself in the headphones, delayed. So this time I'm going to let the intro start moving down, or I'm gonna let the yellow snow hit me, okay? And right away I'm gonna reset the game. And what I'm looking for is if the timer is going to reset my game after, say, 4 more seconds or something like that. So I'm gonna play. Okay. Now I'm gonna let the yellow hit me, and right away I'm gonna reset it myself. Now I'm looking for, does the game reset after a couple seconds? Or does the intro come down? And it looks fine. Okay. There's another subject we can jump into real quick, which is making the text look nicer, making the bubble text. And I'm not going to get into the maths of how it works. There's a couple different algorithms we're going to use, and I'm probably going to make a standalone video on this later on. But we're going to use the standard sine cosine. There is a way cooler algorithm, but I think it takes longer to explain it. But it's a much better algorithm that I prefer to use. But for simplicity in this video, we're gonna work on that one. So we're gonna use the polar coordinates trigonometry algorithm, the one that uses radians and radius and sine and cosine and all that stuff. So what we want is we want the text to look better. We want it to look like bubble text. And there's no way to make bubble text that I know in SDL2. Like, you have to do it yourself. And so this is just kind of a little hack to do it, or I don't know. So we need the math library. So right away, I'm going to go into main H, and I'm going to add the math library. And this is we're going to need to add this to the makefile as well. So we have the math library, but this won't compile like this. We need to go into our make. I may have done it on my own because I've been working on this. So what's happening here is math is part of the standard library. So package config is not going to be able to find it, right? But at the same time, the linker, even though it's part of the standard library, it wants to know about it. So we need to do the -lm, and you can put it before or after, however you want this to happen, but I just put it at the end. And we only really need it on the libs base, I believe. Excuse me. Also, I can confirm that this makefile absolutely works in Mac, because I was trying that out, even though I'm not on a Mac right now. But one thing I did notice is that the sanitizer stuff doesn't find memory leaks, so I'll have to look more into that. But other than that, it completely works on OS X. Windows, maybe, I don't know. So anyway, so for the math library, we need this -L, which is stands for lib. So we're looking for libm. -L m is what we need in there. And that's going to need to be in your makefile. Okay, so we have math added to H, right? Wait, what did I not add A here? Oh, it's here. I added it here, sorry. Okay, that's fine, as long as it's in there somewhere. Okay, but we have another problem. We need pi, and pi may or may not be defined by the math library, depending on your operating system, depending on your compiler, depending on what version of the compiler. It's a bit of a strange one. So what I'm going to do is we're going to define it ourselves. So in title C, I'm just going to put it up here because this is the only place I'm using pi. But we're going to put it like we're going to put an include guard on it. So if it's already defined, we're not going to define it. But if it's not defined, we're going to define it. So we're going to say if in def, if not defined, m pi, okay? And then we're going to define it. This is just like the header guards, you know. But we just need to know if pi is defined. Sorry, I should have put pi here. So that's 3, 1, 4. Well, that's a big number. So we got 15, 9, 2, 6. This is a whole. Let me see if I can just. Let me just do something like this. I'm sure a bunch of people have already done this a million times. Can we get some? Here we go. Here we go. Good enough for me. This number, I trust it. Because I don't know pi and I'm not going to calculate it. Okay? And then we're going to do the NDiff on it. So basically, if your math library has, or your language, your compiler, whatever, your operating system, something, if this is already defined, we're not going to step on it. We're going to let that be. But if it's not defined, we're going to define it. Okay? So that's going to give us access to pi. And we're going to add a couple things to title H. We need we got the text surf. I'm going to add a target surf. There we go. Let's see here. What I called it? Yeah, target surf. Okay, so we have our target surf. I think everything else is the same. Okay. So that gives us access to the target surf. So let's make sure we clean it up before we forget about it. So right here, let's do SDL3 surface T target surf. T target surf equals null. Okay. So that's taking care of the cleanup of that. All these functions down here are all going to stay the same. Nothing's changing here. All the work, all this stuff is going to happen up here. So we're going to need another color. And what I'm going to do is I'm going to use white and yellow, and I'm going to make the outside of the color yellow, which we've already done, and the inside white. So let's save this file. And we need to get to, oh, we are already in the file. So right here, so SDL color, and this one will be called center. Color equals, and it's just the same, except it's just all white. Okay, so that does that. Now we have this, where did we do it? The size of the text. We have the size of text, right, which is an int. We are also going to make a radius. So when I say radius on this one, what we're going to do, that the whole idea of this thing is we have this, let me show it to you real quick. Oops. Oh, I might be able to show you. So what if I, not C++ version, yeah. I'm not going to go through the code of this. I'm just going to show it. If it runs, hopefully it does. I haven't. Okay. So this is what we're going to do. So you see that it looks like it's like a balloon text, or it's got a border around it. But all I'm actually doing is I'm making a surface that is blank, that is bigger than my text surface. And then I'm taking the say bubble text. I'm taking it as a pink color, and I'm stamping it around in a circle. Like I'm just printing it to that surface over and over again by doing it in a circle. And then in the very center, I change the color and stamp it again. And that gives us the effect of like a bordered text or something. And now we only need to do this once when we're starting up the program. Now that we're going to convert it to a texture, we don't have to recreate it again. So this whole stamping process happens one time. It's a one-off thing. But this is kind of what we're aiming for with this bubble text. But it's gonna say yellow snow. So yeah. So we need a radius. So I'm gonna make the radius. Now the radius is the center, of a circle from the center out, which is going to be how thick border is on our text, right? So it's going to be an int radius, and I'm just going to say 10. And what else do we need? We need a radius. We got our two colors. We still have our yellow snow. That's still there. Fine. We still have our font. It's the same. Nothing's changed with that. But we do have a difference now. We are still making the text surface. However, what we need is a target surface now that is bigger than our text surface. Okay? So yeah, so let's do that right here. I don't think we're going to be using these. So we need to make a surface. This is a SDL create RGB surface. Basically need a blank surface. Okay. This is just going to return a surface, and we have the, let's see, flags are unused, should be reset to 0. So we're not using a flag. We do have a width and a height, and we have a color depth, which is going to be 32 bits for us. And then we have these masks. These were confusing to me. So I wanted to set these 0 to 255, but that's not what we actually need. What we need is these hex values, because if we say I want a see-through surface and I just say RGB is all zeros, that's going to be a black color, but then alpha is 0, and that should be transparent, right? But it doesn't work that way. That's not how it works. Now, if we do this thing right here, we're going to get a black surface. We're not going to get a see-through surface, unfortunately. Using 0 results in an yeah. So anyway, so what we're going to do is we're going to be using a hexadecimals instead, specifically so we can get this surface to be see-through, because I want a surface, but I don't want it to be a black square on my screen. I want just to see the text that we're going to put on the surface. So we're going to create this. You're going to see it. We do need the surface to be, we have to think about this. Whatever the text we made, we have the width and the height of that text. But if we're stamping this text around in a surface, we actually need not the radius of the circle bigger than the text. We need the circumference, or sorry, the diameter. So the radius times 2. So when we stamp this around in a circle, the surface that we're stamping to needs to be the size of the text, but it also needs to be 2 times the radius, width, and height. That needs to be added. So we can just call this padding. We'll just say int padding equals radius times 2. Yeah. And that's just giving us a diameter is what it's doing. But it's going to be the padding for what we're making. So, okay, so we're going to be doing this target surf. T target surface. This is just going to make a blank surface. Nothing's going to be on it. But it's going to allow us to stamp the other one. Create RGB surface. Now, oops. Now what's going to go in here? First, it's going to be 0 for the flags. Now it's going to be the width. And what width we're using is actually this surface plus this padding. So we can say T text surf. We're not even setting this rect up here. This is going to go away. W. So we got a width plus padding. Okay, and that's going to be the width. The height is going to be the same. T text surf H plus padding. Okay, so now we get into the RGB of it. Okay, so it might be set up as a RGB. That seems to be how I have it set up for an RGB surface, I guess. So we're just going to use what I have. I initially had just zeros, and it was giving me a black. So on my demo here, this one, since it's already on a black background, I believe that it's black. So it's not really see-through, which is a problem for us. We need it to be see-through because we're not using a black background. So the red is not going to be the most significant bit. It's going to be the second bit over. So this is what it's going to look like. It's going to be, this is in a hexadecimal 32-bit. So it's going to be 0x and then 00 FF 0000. That is our red channel. I wish it was all on one line there, but anyway. So our green channel is going to be the same, except the F's are going to be moved over. So we're going to say 0x, and we're going to have 0000 FF 00. And our blue channel, same, but the F's are moved over again. So X 000000 FF. And now our alpha channel is actually the most significant bit. So 0x FF 000000. That should be correct, hopefully. So this should give us a transparent surface. Okay. So there's our target surface. And now we need to check to see if that target surface really does exist. So we're going to use this same right here. And we'll too few arguments. Oh, sorry. Before these, right here, it wants to know the what is it? This one right here needs to be 32, which is the depth, the bit depth. I didn't put it on there, so it's 32, and there we go. So now we're going to be checking to see to make sure this target surface was actually created. So we got our target surface. Our error message is the same. Okay, so now we have a target surface. Now we have to do the algorithm. Okay. So we'll just say, because we might put a different algorithm in here later. We say polar Hopefully that's all right. I'm sure I spelled algorithm wrong. Anyway, so that's the algorithm we're using. So we're going to use a for loop. So we're going to say for int index equals 0. And then we want the index to continue if it's less than, we basically I only want to be incrementing it like if I'm going around a circle one at a time. So like if I'm going around the circumference of a circle, that's, so I'm going to be stepping it for each. I'm not trying to calculate, because you could calculate a circle that's 10 by 10 a million times, and you're going to get the same number most of the time until it moves over to the next pixel, moves to the next pixel. So I only want to do it whatever the circumference is. So that is going to be the pi, 2 pi times radius, right? Which is our circumference, our diameter, diameter times pi kind of deal. So that's what I'm going to be doing. I'm going to say y index is less than, and this has to be cast to an int. 2 times pi times radius. Okay, so it's going to be incrementing, or it's going to be until that is breached, and then it's just index plus plus. Okay, so that's going to be our for loop. Now, what we do, we need the radians. Now, this is not a math tutorial. I'm sorry. I'm not going to be explaining all the math because I probably will not do a very good job of it at all. So if you want to know the nuts and bolts of how to draw a circle with sine and cosine, just you can look that up on some math sites or Wikipedia or something. For this, we're just going to implement the thing. We're not really going to, I'm not going to explain it very well because it's not a math video. So I need radian. It's going to be a double because the cosine and sine math functions are looking for a double, I believe. I'm just going to call it rad. And this is going to be cast to a double. And it's going to be the index divided by the radius. Okay, so that's going to get our radian. A radian is going to be that. And now we are going to say int x equals, wish that would go away. Go away, go away. Why are you there? Okay, int x equals, and we've got to cast this to an int. And this is going to be cosine rad times radius. Now the problem with this is, so I'll show you the other one too. Int y is going to equal, and we're going to cast it to an int, and this is going to be sine radian times radius. Radius. Okay, so the problem with this is this going to make a circle, but it's going to make a circle that we're only going to see a quarter of it in the top left of the screen. You know what I mean? It's the circle that it's drawing is imagining that the top left, the origin of your screen, is the center of the circle. So we need to move that circle by the radius to the left and down by the radius. So what we're going to do on both of these is we're going to add radius to it. Sorry, I'm going to do it in parentheses. So this is just going to offset it. So now this is going to draw a circle that is has a diameter of 10 pixels, and it's going to be in the top left-hand corner. We're going to see the whole circle. And what we're going to do is, instead of drawing a circle, we're going to be stamping our text, but our text is always going to be seen. And since our surface is big enough to hold it, it's going to make that effect that we saw with the bubble text. So we offset both of those with the radius. And now since we have the number, we're gonna use SDL blit surface. So we are using a surface and we are putting the surface onto another surface. So this is not render copy. We're dealing with software surfaces right here. So we're using SDL blit surface. Yeah, let's look it up real quick. Okay, so we have our source surface, and then we have our source rectangle, then we have our destination surface and our destination rectangle. Yeah? So we're blitting from one surface to another. And this our source surface is going to be the text that we've already created, and our destination surface is going to be our target surface. Okay? So and we're our source rect for our source surface is going to be null because it's the entire surface. But the destination one is going to have a width and a height. Yeah, we're going to see that here in a second. So this is a SDL blit surface. Again, this is a whole software thing, but we're only doing it one time in the game, when the game launches. We need our text surface. That's the one that we want to stamp with. Okay, we got our text surface, and we want all of it. So that's our source. This is our source surface and our source rect. Now we have our target surface, which is T target. And that's what we've just created up here, this big blank surface that's bigger than our text surface that we're going to stamp in a circle. And now we are going to generate a rectangle. Okay, like we're just going to create it right here. So we're going to get the address of the SDL rect. Because this rectangle is going to be changing over and over again. We could create it outside, but I'm just going to make it right here. So it's going to be x, y, x, y, and then we have our text surface width and our text surface height. So width, text surf, height. So that's going to get our width and our height. And that is the end of that. Okay, and we're not checking this one for failing. So this is going to blit this around in a circle. It's going to take our text and it's going to blit it around in a circle. And this is going to give us a, this isn't going to have the center stamp yet. So we're just going to see the yellow, a kind of a bubbly yellow without the center color. And let's just do this needs to be from the target surface now. And also where we were getting these here, I'm going to delete these here. And these are actually coming from the target surface. Because that's the bigger one. That's the one that we're actually going to be converting to a texture. So this will be target surf, target surf, surface twice. Okay, so that's going to populate our rect there. And now this needs to come from our target surface. And it's still going to the image. And we're still freeing we can free both surfaces here. We can do SDL free surface the target surf equals no. Okay, so all that code should work. So now if we play this, we should see a yellow text, but it's more, it's like it's been stamped around in a circle. Let's just see if that works real quick. I could have made some mistakes. So. It's unused. Since it's unused, we'll just comment it out because we will be using it in a minute. It's the center color. Okay, so do you see how that's now like a little bit more round, bubbly than it was before? And we could make it a bit bigger, maybe. If you go too big with this, I'll show you, you'll get artifacts because this is just stamping around circles. So if I were to say like 50, it would have like holes in it and stuff. So you would have to think about that a little bit more if you wanted it like that. Oh, it doesn't. It's not too bad, but it's a little bit goofy. So, and it also has little artifacts, kind of, you know. But it works good enough for making a bubble text. But let's say let's put it at like 15 or something. Okay. And we know that works now, but we want to stamp the center color. So what I kind of want is the center color to be white. So what we do is after we've done this algorithm where we stamped everything around in a circle, but before we convert that to an image, I want to recreate so I'm gonna do this here. I'm gonna free this surface twice because I'm gonna reuse the surface. The text surface. Let's yank it. So I'm going to free it. I'm going to recreate it. This text surf right here. Just doing the exact same thing we did before. Okay, but this one I'm going to say center color. Center color, did we Yeah, we undid it. So we got the center color. Now we need to stamp it one more time. So I'm just going to grab this function right here. And so we have freed the old surface. We've created a new surface of a different color. And now I'm going to stamp it one more time. And for the X and the Y, I'm going to use radius because I just want it pushed in and pushed down, the amount of the radius to get it centered. Radius, that should still work there. Hopefully that all works. And then we are converting it to an image like we always did, and then we can free that up. Everything else should still be the same. What did I do here? I missed the semicolon right here. Okay. And now it looks a little bit nicer than it did earlier. Why is the snow not fall? Let me just check that again. I'm going to rebuild the whole thing. Okay, there's the snow's falling. Yeah. And now if I play and I go out, I've paused the music so it's not playing. Now it comes down again. And it should just hold on to your score. Let me check real quick. If I get some, I got 4 points and then that goes out. I didn't reset the score because, maybe you stepped away and you wanted to know how far you got into the game. So the score is still there, but it does reset when you reset the game. So that teaches you kind of how to make bubble text or outline text in SDL using the normal sine cosine algorithm. It also shows you how to put an event on the event queue, how to make your own event and push it to the event queue. So that's quite a lot for this video, I think. We're at 1 hour and 10. So I didn't. We could have checked errors on these blits. So I didn't check. Let's see. Does blit return an error? Does return an int? Yeah. So I could have checked errors on these blits. I didn't. It's kind of here or there. You can be really strict, or you can just say, if one of the blits failed, you can kind of decide. But this is doing a whole software thing, but then it converts it right away to a texture, and then that texture is used throughout the rest of the game. So what we've done here is we've kind of just created this brand new surface, and we've made it where it is transparent, and it's bigger than what the target is, so we have the room to make the circle in it. And then we have basically stamped that text that we've already created around in a circle using the polar coordinate trigonometry algorithm that I'm sure I spelled the algorithm wrong. And then we are releasing that surface and recreating it with the other color, the center color, and reblitting it in the center, and then we're converting that target surface to our image now. I am releasing the surfaces here, but I also release them in the cleanup at the same down here. Just so no matter what happens, wherever it errored, I am releasing those surfaces. Okay, and that's going to be it for this video. I hope you enjoyed and possibly learned something, or if you have any problems or questions, just leave comments in the comment section. And see you in the next one. Thanks. Bye.